Here I made it more complex, so let's reverse it. And so what we can do here is take the reciprocal for both sides, and we get 1 minus y over n over y is equal to 1 over j, which is another constant. So let's rename this constant to b, multiplied by e to the power of negative rx, since 1 over e to the power of rx is e to the power of negative 1 or negative rx. And so here let's separate this term over here, and let's divide 1 over n minus y over n over y, and we get 1 over y minus y over n over y. And here we actually get, because it's y over ny, we get 1 over n is equal to b e to the power of negative rx. And let's take the 1 over n to the other side by adding 1 over n to both of them, and we get b e to the power of rx plus 1 over n. And so let's now solve for y by just checking the reciprocal again, and we get y is equal to 1 over b, or let's write the n first, 1 over n plus b e to the power of negative rx. And since n here, and let's clean it up by just multiplying the numerator and denominator by n, we get y is equal to n over n plus n multiplied by b is another constant, so let's replace it with k. So k e to the power of negative rx, where n is the limiting factor, k is a constant, and r is another constant. And so let's write it by its own here. So y is equal to n over 1 plus k e to the power of negative rx. And here we found the original function of the logistic growth, and we know its derivative is dy over dx is equal to ry multiplied by n minus y